Good day, everyone. This is a discussion about reliability tests using the method Kuder-Richardson Formula 20 for the measure of internal consistency. This video was made for my class, for my students on the course Assessment of Learning 2. If you recall the types of reliability measure, we have measure of stability, measure of equivalence, measure of stability and equivalence, and measure of internal consistency. For today's discussion, we'll be talking about the method Kuder-Richardson with the statistical measure, the KR20 or the Kuder-Richardson Formula 20 and KR21. The procedure: give the test once, then correlate the proportion or the percentage of the students passing and not passing a given item. So KR20 is a measure reliability for a test with binary variables. We have the answers that are right or wrong. So this could be used for identification type of test, multiple choice, or true or false type of test. Now remember that reliability refers to how consistent the result from the test or how well the test is actually measuring what you want to measure. So KR20 is used for items that have varying difficulty. On the other hand, KR21 would be used for items that have the same difficulty. So again, KR20 is used for items that have varying difficulty. For example, some items might be very easy, others more challenging. So this should only be used if there is a correct answer for each question. So for Kuder-Richardson Formula 20, we'll be using this formula. So this is K divided by K minus 1 multiplied to this bracket 1 minus the quotient of the summation of PQ over S squared, or that's the variance. So where K is the number of test items, P would be the proportion of the examiners who got the item correct, and Q would be the proportion of the examiners who got the item incorrect. S squared is what we call the variance. That's the square of the standard deviation, and the summation of PQ would be taken as well. For the interpretation, take note that 0, if we have a result of 0, there would be no correlation. Well, practically we're not talking about correlation here, but we are taking the result of the measure for Kuder-Richardson 20. So your result would range from 0 to 1. The closer to 1 would be more reliable. The closer to 0 would be unreliable. Okay, let's go to our example number 1. So a 15-item teacher-made test was administered to 12 students, and the item analysis were recorded below. This would be the table. So test the measure of internal consistency of the teacher-made test using Kuder-Richardson Formula 20 or Kuder-Richardson method. So considering that this teacher-made test has varying difficulty, so there are 12 students from A to L, that's 12, and the items 1 to 15. So the first thing that we do is to get the total score for each student. By the way, the coding for recording the item analysis is binary. That's 1, 0. So 1 would mean correct response and 0 would mean incorrect response. So for example, for student A, the incorrect item would be item number 14, while the rest of the item was correct. So we get the total score for student A. Let's use the formula for sum. Gather all the cell, then press enter. So For student A, the total score this student got is 14. Okay, so we follow or copy the formula for the rest of the 12 students. So as you can see, student 12 or student L got 0, student K got 1, and student D and student B got a perfect score. Okay. Next thing to do is to get the total correct response per item. So just simply add all the correct response for item number 1. So that's equals, and then sum. Then we get this or we highlight this cells here, then press enter. So the total correct response for item number 1 would be 9. Then we copy the formula. There you go. For item 2, that would be 8 total correct response. Item 2, 3, 4, that would be 8 total correct response. So item 5 to 8, all are 7 total correct response. For item 15, the total correct response is 4. Next, now we go to the proportions. Proportions, or normally that's the percentages. So for P, that's the proportion for the correct item. So for item number 1, 9 students got the correct answer out of 12. So 9 out of 12 students got item number 1. So meaning that's 9 divided by 12. So in our formula, that would be this cell containing 9 divided by the total number of students or respondents, that's 12. So that's 0.75 or 75%. Drag the formula. There you go. So we have, for example, item number 15. This is just 33% correct response. For item, say, number 9, that's 50%. That's 6 out of 12. Okay, so we're done with P. We now proceed to Q. Q would now be the proportion for items which are incorrect. So normally we just deduct this proportion from 1. Okay, so if this is 75%, this should be 25%. To do that, this would be equals 1, that's 100%, or 1 in decimal value, minus our cell containing the 75%. That's actually D49. It's covered on my formula. Okay, but just to check, so we have here 100% minus 75%, that should be 25%. The total of these two is always 1 or 100% if we are talking about percentage. If we are talking about decimal number, it should be 1. So if we copy this formula, that would be the result. So notice the sum of this pair should always be 1. Okay. Now we get the product, that's P and Q. So we simply choose D49 multiplied to, that's asterisk, that's D50, then press enter. So again, I multiplied 0.75 and 0.25, that's multiplying P and Q. So your formula, that's D49 multiplied to D50. Okay, then you just simply drag the formula and it will perform the rest of the formula or the multiplication. I place a space here, or something that you could box. So you actually need to get the summation of PQ, because in our formula summation PQ is needed. Okay, so press equals, then choose sum. Okay, if it's not here, you can always click and find more functions. Just to show you, let me just choose that method. So I'm gonna look for sum, that's SUM. There you go. Then choose OK. Then again, drag all the cells, or choose all the cells included this area for the summation of the product of P and Q. Press enter, and you have 3.5069. Okay, that's summation of the product of P and Q. So we now go to our solution. Okay, so just we just simply complete this table. I already prepared it so it could be organized. So in our formula, we need a K, that's the number of items. We need the summation of PQ, or summation of the product P and Q, and we need the variance, the square of the standard deviation. So our K here would be 15. Our summation of PQ would be, let me just choose this cell, equals S51, and it will automatically copy whatever is placed here. So that's 3.5069. And then the variance, we'll be using the formula for this Microsoft Excel. Press equal sign, and then we'll look for var p. It's already here, but if you don't have it on your formula area, I'm gonna choose more function, and then let's look for var p. That's variance p. There. So it calculates variance based on the entire population. We also have var s, that's for estimation of the sample, but normally I would suggest the calculates variance based on the entire population, var.p. Okay, then press OK. Now we are going to choose our array of numbers on our table. Let's just go back to our table, and we'll get the variance of the necessary data. We are now going to choose the total score, since this is the array of numbers that we are computing. We are calculating the variance based on the entire population. So press OK. So the result is 35.74306. Now I have here a shortcut. Okay, let me just show you the first method that I'll be using. So press equal sign. I'll follow this formula. So this is my first factor. This would be my second factor. Or simply, okay. So I place two parentheses. This would be my first parenthesis multiplied to my second parenthesis. Then on my first parenthesis, it's actually a quotient, so I'll place a forward slash there, okay, as our operation for division. So my numerator, that would be the value of k, that's 15. Then my denominator, it's actually a binomial, so I'll put another parentheses, and that would be k minus 1. So k minus 1, this is k, value is 15 minus 1. I'm done with my first factor. Second factor, I have 1 minus, then this is quotient. Summation of PQ would be 3.0 or 3.5069 divided by the variance S squared, which is already here. I choose D56, then press enter. Okay, round that off to 2 decimal place. That would be 0.97. Okay, so for beginners, I'll show you another method of solution. This would be using a calculator. So first thing that we'll do is to follow the formula. We'll just have to place the value for k, summation of PQ, and the variance. So the k value is 15, and another k value here, 15. Summation of PQ would be 3.0 or 3.5069. Then the variance, that would be 35.74360. Okay, so to properly visualize this operation or this formula, you'll be needing a calculator. Okay, most of you could use your calculator, your cell phone, or a pen and paper so that you could visualize it properly. Now notice I have two factors here. I'll simplify 15 divided by 15 minus 1 first. So 15 divided by 15 minus 1 is 14. Let's enter. I have 1.07 rounded off to, or I could take the 4 decimal place, 1.0714. Okay, the next factor, this is 1 minus the quotient of 3.5069 divided by 35.74306. Enter. So check, they are the same. I was able to place it properly. So the result up to 2 decimal place, 0.9018. 0.9018. Okay, and then multiply this 2, you have 1.0714 multiplied to 0.9019. That should be 19, rounded to the 4th decimal place. Okay, so your result is the same with 0.97. So we round this up to 2 decimal place, 0.97. Let me just update this to 9. Okay, so double check. Okay, that's correct. There you go. My result is correct. Now, going back to the interpretation, you should be able to interpret the result. So the KR value is 0.97. Okay, it denotes a very high relationship. Hence, the teacher-made test has a very high reliability. So there you go. This is a reliability test using the Kuder-Richardson Formula 20 for measure of internal consistency. Thank you for watching.